Notice it's a positive out front, and that's an x to the first, and that's an x to the second. So it's basically going to be a skinny 2x cubed. X cubed is down on the left, up on the right. That's going to give me either choice A or choice D. It cannot be C because that's the wrong end behavior. Now I'm going to inspect the zeros. It has a 0 at 0. So that one goes through 0. That's good. Oh, that one goes through 0 as well. It's still a toss-up. Now, the factor is x minus 2. That means it's going to go at positive 2 is going to be a 0. That one doesn't have a 0 at positive 2. It has a 0 at negative 2. And what's nice is at positive 2, it bounces. That's what that 2 means there. That means multiplicity 2, and multiplicity 2 is going to touch and turn. Negative x squared, x to the third, x to the fourth. It's going to be negative 2x to the fourth is the overall equation. That's going to be down on the left, down on the right. It is now a toss-up between between choice A and D, all because of that negative. Now, I notice it goes through 0 and it's squared, so it touches and turns at 0. Well, that one touches and turns at 0 again. It also touches and turns at negative 2. And it has to be choice D. Vuxoid, horizontal asymptote, vertical asymptote. Vux, that's x equals. So I have a vertical here at x equals negative 2. I have a vertical vertical over here, that's y equals positive 2. I now need to discuss a HOI. The HOI is going to be a horizontal line. Notice, I'm going to do the HOI note like this. That's going to be y equals a number, so it's a horizontal line for the horizontal asymptote, and that goes to negative 3. The horizontal asymptote is going to be y equals negative 3. So I got a horizontal at negative 3. They tried to trick me up here with choice A, and a vertical at x equals negative 2 and 2. It's going to be choice B. All right, these rational expression problems are kind of complicated. First, we want to set the bottom equal to 0, so what would make that 0 would be negative 2. So that means it's going to have a vertical asymptote at x equals negative 2. Notice this one has a vertical asymptote at x equals negative 2. This one has a vertical asymptote at x equals negative 2. Oh my God, they all have a vertical asymptote at x equals negative 2. So I'm going to erase the vertical asymptote and look at it a different way. If it didn't have the square, it would be going down and up. And we'd have to make a choice between choice A or choice C. It would be one of those. However, because it is squared, that means it's either going to be a volcano or a tornado, because it's x squared. Now, because it has the negative, that's going to make it this one, a tornado. Some people call it a toilet bowl. So in this case, it's going to be choice D. If that were a negative on top, it would have gone up. It would have been choice B. But because it has that negative, it's going to be choice D, or tornado, or toilet bowl, whatever you want to call it. Wants to know the horizontal. Horizontal asymptotes are found by looking at the degree of the top versus the degree of the bottom. When the degree of the top is the same as the degree of the bottom, notice that's 1 and that's 1, we can just do this. Y equals 2x divided by x. That's going to give me y equals 2. So the answer is A. But I want to find the horizontal asymptote of this one as well to continue the exercise. Little education here. So I can ignore the back part, and that's going to be y equals x over x. And we'll notice that that's y equals 1. The horizontal asymptote for B is y equals 1. Now for this one, it's going to be y equals 2x squared over the x term. That simplifies to y equals 2x. Now, that is not a horizontal line. That's actually a line that has a slope of 2. That's what we call an oblique asymptote. So the rule is, if the degree of the top is bigger than the degree of the bottom, that will not give us a horizontal. That will give us an oblique asymptote. Now, this one, the degree of the top is smaller than the degree of the bottom. That's going to give me y equals 0 as my horizontal asymptote. Now we're looking for a vertical asymptote. In order to find the vertical asymptote, all you need to look at is to set the bottom equal to 0. So when I solve that, that's going to give me x equals 3. So once again, just by coincidence, my vertical asymptote is A for x equals 3. When I set this bottom equal to 0, I get x equals negative 9 as my vertical asymptote. When I set this one, the bottom equal to 0, that will give me x equals negative 9 again. For this last one, when I set it equal to 0, that gives me a vertical asymptote. Remember, it's a Vux. X equals -3. So it's going to be choice A. Find any vertical asymptotes. This one is really tricky. I set the bottom equal to 0. And when I solve it, I get x squared equals -1. Then I square root both sides. And notice, when I square root, I add the positive and negative. But that's going to give me plus minus I. Square root of -1 is equal to I. So this particular problem is not going to have any vertical asymptotes. It has a horizontal asymptote of y equals 0, but the vertical asymptote, the bottom will never equal 0. This is actually called a witch. The graph would look something like this. A little strange. Actually, it goes through 1. Like I do a better graph. The graph actually goes through +1. So it would probably look like this. And it's called a witch. Kind of neat. This one, vertical asymptotes, I set the bottom equal to 0. I can factor that. Other people solve it for x, or you can factor it. That's going to be +1, -1. Difference of 2 squares, so that's going to be choice C. The horizontal would be the degree of the top is smaller than the degree of the bottom. The horizontal would be y equals 0, but it doesn't ask for that. Find the horizontal. The degree of the top is the same as the degree of the bottom. So I'm going to write down 5x squared divided by 5x squared. All you do is ignore those back numbers, and that's going to equal 1. So my horizontal asymptote is y equals 1. Horizontal asymptote. Notice the degree of the top is bigger than the degree of the bottom. I instantly know that there is no horizontal asymptote. Horizontal asymptotes. Degree of the top is smaller than the degree of the bottom. That's going to give me y equals 0 for the horizontal asymptote. Again, you can do x over x squared. That's going to simplify to 1 over x. And when you throw in infinity for the bottom, 1 over infinity would equal 0. That's how we get a horizontal asymptote of y equals 0. Horizontal asymptote. Degree of the top is the same as the degree of the bottom. So we're going to write 24x squared over 8x squared. And that's going to simplify to just y equals 3. So my horizontal asymptote is y equals 3. Notice again, the degree of the top is the same as the degree of the bottom. Oblique asymptote. The degree of the top is bigger than the degree of the bottom. So to actually find the equation, we have to implement synthetic division. So backwards box, I put a +3 in the backwards box. I write down the coefficients of 1, 7, and -9. I put my 0 here, and I start the process. 1 plus 0 is 1. 3 times 1 is 3. 7 plus 3 is 10. And then 3 times 10 is, who cares? I don't need any of this over here. I'm done. What this means is y equals 1x plus 10. And that is my horizontal asymptote. And that would be choice A. X plus 4 doesn't work. Y plus 10, they're trying to trick us. Oblique asymptote. Notice the degree of the top is the same as the degree of the bottom. So that means it's going to have a horizontal asymptote. And if you have a horizontal, you cannot have an oblique. There is none. This one, I would enter into calculator mode 7. I would start. When you enter it in, you're going to enter it in just like it looks. So you're going to hit this button on your calculator and use the alpha red X button. And I would enter it in. And when I would start it at -8. I would end at 8. Notice this graph has important information all the way from -8 to 8 in each picture. And I would step by 1. Once you do that, you would look at the -8 value, you would look at the -7 value, you would look at the -6 value, and you would line them up with the drawing. Notice, for A and C, the -8 value is positive. Over here for C, the -8 value is negative. So just looking at that first point, you can get rid of 2 of the equations right away.